Hey y'all, welcome to part 5 of my Gatton CNC router build series. In this episode, I'm going to go ahead and put the linear rails on the CNC table, get the uprights assembled, ready to go, and get them mounted. And here I used a square to locate the center of the slots, and then an awl to make a dimple. Then using progressively larger drill bits, starting with a 1/16 diameter and moving up to 17/64. So the 1/4-20 screws will fit without binding up. And I took a cross dowel and tried my 1/4-20 bolt. Just ran it back and forth a couple times to make sure everything was okay, and did this on all 3 holes. Well, some of the more common questions we get in the Facebook groups come with the washer stack up when you're attaching the V-groove bearings to the X, Y, or Z axis. Now, this might seem self-explanatory to some. Dave specs out everything in the build plans, but occasionally questions come up. And so I figured I'd take a couple seconds and just basically show you what each washer is supposed to do, what it's there for, and let you make your own determination from there. Okay? First of all, don't be, confused by the fact that there's a logo on the inside. This is the outside of the gantry upright. There's the logo cut there, and here is the little recess for the lead nut block. I went ahead and I cut the logo on the inside because I think it looks cool that way. So I'm using the 3/8 16 bolts, but I went ahead and went with a hex head just simply because there are areas on the Z-axis plate where you're not going to be able to get to a screwdriver head, but you will be able to get in there with a couple of wrenches. I went ahead and I bought a box of bolts, and they're all going to be the same. That's just me. So when it comes to the washers, we've got 3 different kinds here. I've got a standard 3/8 inch flat washer, 3/8 inch fender washer. Then we have these little miniature washers that Dave specs, which can be ordered from McMaster-Carr. Now, they don't have to be ordered from McMaster-Carr. The whole purpose of these washers is to act as a spacer that will not interfere with the smooth operation of the bearing. Now, when I show you what I'm talking about here, you'll get what I mean. The first thing in the washer stack up is a flat washer under the head of the bolt, between the bolt and the gantry upright. And that's simply there to keep you from pulling the head of this bolt into the wood as you tighten it down from the inside here. So we'll go ahead and we'll put that in place, get that there. Now, from here, you can go a couple of different directions. We'll either go with a flat washer like this or with a fender washer like that. And it's completely up to you. The fender washer is a little bit more expensive, but not prohibitively so, just, a few cents per 100. The whole purpose of this washer on the inside, be it the fender washer or the flat washer, is to, again, keep you from pulling any of these other washers or the bearing into the wood and keep the bearing from rubbing the inside of this gantry upright. So it spreads the pressure. When you tighten the nut, it spreads the pressure out over a larger area and keeps you from pulling it into the wood. That's all there is to it. A fender washer would spread that pressure over a larger area, but it's also a little bit big, like if you were to do it up here in the corner. Personally, I think that's too big, so I'm going to go with the flat washer here. Okay? Then comes these little special washers. These are simply put spacers. Just a spacer to go over the bolt underneath the bearing to keep that bearing from rubbing against that flat washer. That's its sole purpose in life. Then we'll put another spacer washer there. Then we'll put the nut and tighten the whole thing down with a set of wrenches. Now, when it comes to tightening these bolts down, we do not need 150 foot-pounds of torque on these things. All we need to do is snug them up so that there's no play in the bearing this way, but the bearing will still spin smoothly. That's supposed to be the purpose of these spacer washers. So when you get it tightened down, go ahead and spin it. If it doesn't spin freely, it's perfectly fine to add another spacer washer, till you get to the point to where this spins freely without a bunch of play. The only caveat to that is, if you have to do that on one bearing, do it on all 6 of them in the case of the gantry upright. Do it on all of the bearings if you have to do it on one. The reason for that is we want these bearings to be in line with one another so they'll ride on our linear rail here evenly. If we have 2 washers here, 1 washer back here, the front end is going to be kicked out away from that linear rail. We want this to run parallel with that linear rail. So if you do a washer stack up that's a little bit different on any of these bearings, do it on all of those bearings so that they're all running the same way. Okay, I decided to go ahead and tighten a couple up just to show you what I'm talking about here when I say we don't need a huge amount of torque. Now these are the adjustable ones. I have yet to put in my cross dowels, but we're looking at, come on, that's a bit too tight. I don't know if you saw that or not, but it would not spin. So let me back that off. I still need to be able to adjust these anyway. There we go. That's a good baseline. I've got just a little bit of play in these, but again, these are the adjustable ones. So I'll do one of the fixed bearings here. Whoops. Come on. Come on. Get on there, boy. There we go. Snug. Spins freely, no play. Good enough. Okay, now I've already gone ahead and installed the linear rails on the top of my table, and I have the linear rails attached to the bottom rail piece, but it's just clamped into place for right now until I get everything put on, get it squared up to the table, and am ready to go ahead and permanently fasten this to the bottom of the table. Now I went ahead and I did this side off camera just to make sure I had my methods down correctly. And now I'll show you on the other side of the table how I got it to this point here. Following the suggestion in Dave's build videos, I cut a piece of scrap that was the appropriate width and used it to lay out the upper linear rail on the opposite side. Then used the linear rail itself to drill pilot holes. I then also used the lower linear rail to drill pilot holes. And I did this by clamping it up onto the support brace there. Then using a straight edge and marking out the pilot holes needed to attach that bottom rail support to the bottom of my table. Then using a drill driver to get the screws started, I attached the lower linear rail to the support brace, then clamped it back up and went back and tightened up all those screws by hand. I prefer to do it that way with round-headed screws. That way you don't shear off a head. Then I did the same thing with the linear rail on the top of the table, just using a hand screwdriver to get them started, the drill driver to drive them in most of the way, and then my hand screwdriver to tighten them up the rest of the way. So with the uprights assembled and installed on the linear rails, it's now time to go ahead and square them up to the table and lock down that lower rail permanently. Okay, just a little bit of scene setup here. What you're looking at here is the gantry upright. This is the rear of the upright, and the back of the table frame is that way. This up here is the front. Well, what we're going to do right now is adjust these lower bearings here. Now, they're still loose. You can see them and probably hear them rattle. And I've got my adjustment screws down here. Now, I have hex head screws in here, but that's only because that's all I have right at the moment. In my case, I need 1.5 inch long, 1/4-20 screws, and I don't have any 1.5 inch long machine screws like this. This is the type I would prefer. I'll probably swap them out a little bit later on, but for right now, this is all I've got, so I'll make do with what I have. So, what we're going to do now is we're going to adjust these bearings up to capture this lower rail here. And we don't need, we need to keep a sense of perspective here and remember the purpose of these bearings. All these bearings do is capture this rail and keep this gantry upright from shifting upward with the forces of the z-axis. That's all we need to do. We don't need to torque these suckers down to 150 foot-pounds. In fact, over-tightening them leads to a lot of the wear on the linear rails that people are concerned about. So, first thing I'm going to do is I'm going to bring these up just finger tight and finger tight again. In fact, I'm going to use the socket with my fingers just because of those points, and I am not torquing these down at all. Finger tight, they're against the rails, and I've got nice free movement. In fact, that might be a little bit much. And this is one of those things you're going to go back and forth with and do several times. Okay, there we go. We're moving nice and smooth now. Again, I'm not taking a screwdriver or a wrench and really torquing down on these things. I'm just capturing them. Now you're going to ask, well, won't the z-axis forces pushing down on the material, won't that try to lift these up? No, it won't. There's 3 bearings here, and that's why there's 3 bearings here. It may push a little bit, but remember your bit is also cutting. And if, to be honest, if the forces of your z-axis are causing this to lift, your plunge rate is probably too high, and you need to go back and kind of look at your tool paths a little bit. Or your bit is way too dull, or something isn't right. It should not do this. The bit should be cutting into the material as it pushes down. So, that's about right for up here. Now I'm going to push it down towards the rear and adjust from there. And this is a back and forth kind of thing. It's nice and smooth right now up here towards the front. So I'm going to go back and check it, and we'll look for that happy medium. Okay, I've gone back and forth with this along the length of the table, and I've checked it, and the bearings are adjusted just fine. Now it's time to go ahead and take my wrench and socket and snug these up. Now, a couple of words here on doing this bearing adjustment. Number one, as I said before, the purpose of these bearings is to capture this lower rail. It's not to pull this upright downwards. If you're moving your upright back and forth along the rail here, and you see that one of these top bearings is not turning, there's something else wrong. Don't come down here and try to adjust it out with these, because you're putting more pressure on the rails than it needs to be. You know, maybe you got a bent bolt. First thing I would do would be swap out the bolt. After that, if it's still the same, I would maybe come back and address the holes. Now, Dave cuts these on the CNC, so they're accurate, but things happen, things change, so you might need to enlarge the hole, say a 64th, and adjust that bearing. But the important thing to take out of this is, if you have a bearing up here that's not turning, don't try to adjust it out down here, because you'll just pull that down even firmer than it needs to be, and that's where you start getting into the wear of the aluminum rails that everybody is so concerned about. So, with this side done, as I say, I'm going to go ahead and tighten these bolts up and check my operation again to make sure it's nice and smooth. And if everything is okay, I'll move over and do the other side exactly the same way. Okay, this rig that I have right here is a spacer that I've set up and clamped to the gantry upright. And what this is for is because with the aluminum rail down here and the bearings and everything else I got going on down here, I can't physically get my square up against the side of the upright with the blade on the upright and the tongue on the table of my framing square here. So I had to take a couple of pieces of MDF, which are nice and flat and smooth. I've got a 3/4 inch piece here and a 1/2 inch piece here, and I have them clamped firmly in place to the upright. And what this does is it gives me a nice flat surface that I can reference my square off of. So I can bring it up here, and I've got the tongue of the square flat against the table. Bring it up, and you can see I'm nice and square. You don't see anything shining back behind there. I'm nice and straight. If I was off a little bit, if I had a gap down here at the bottom and no gap up here at the top, I would need to loosen up the clamps on my lower rails and bump them in slightly. Not hitting on the aluminum, but just the wood piece that the aluminum rail is attached to. If I had a gap up here, I'd want to loosen up the clamp and put a screwdriver or something in between the lower rail mounting piece and the table frame, and just kind of bump that out slightly. To just the whole game here is to straighten up this upright so that it is square to the table. Now I've got it set up here at the front. I'm going to tighten my clamp up. I'm going to move to the back. I'm going to do exactly the same thing. Then I'm going to come back, stopping about every foot along the way, and spot check along the way 3 or 4 times. And that's just to make sure that it stays nice and straight the whole travel of the aluminum rails. Then once I have that set and clamped down, I've already got some wood screws down here started in my lower rail mounting piece. I will go ahead and screw that down and make this permanent. With the upper and lower linear rails mounted to the table, the gantry uprights assembled, the bearings adjusted, and the upright squared to the tabletop, we'll call this the end of episode 5. Now I know that this was a very long video, and I do appreciate you sticking with me through it. If you got anything at all from this video, please hit that thumbs up button down below. They really do make a difference.
As usual, if you have any questions or comments, please put them in the comment section below. Now I'll put a link to Dave Gatton's homepage in the description box where you can get more information on a Gatton CNC kit of your own. I'll also put a link to a playlist of all the videos for this build down in the description box below. If you'd like to follow along with this build, consider subscribing to my channel. But whether you subscribe to my channel or not, I'd like to thank you very much for taking the time to watch today, and y'all take care.